1 says that we have to express 4x squared plus 12x plus 10 in this form, ax plus b whole square plus c, where a, b, and c are constants. Okay, so you can use the method expansion and comparing, or you can use the identity method, which I'll be using here. So this can be written as 2x whole square, then plus 2a, and what should b be so that we get 12x back? It's going to be 3. So then we'll have to add square of 3. And to undo that, we'll also have to subtract square of 3. And there's a 10 in the question already. So these three combined will make 2x plus 3 whole square. And these two combined would make plus 1. So this is the completed square form of 4x square plus 12x plus 10. Okay. Part 2 is function f and g are both defined for x is greater than 0 and fx is equals to x square plus 1. And fg is equals to the same thing. So this is same as what we change into completed square form. So I'm going to write the completed square form instead. So 2x plus 3 whole square plus 1. Now they've given you fx, they've given you fg, and they're asking you what is g. Okay, so g has to be substituted in f to get us this. So now we can clearly see that g must be equals to 2x plus 3. So when you substitute 2x plus 3 in fx in place of its x, then you get this fg. So gx is equals to 2x plus 3. Okay. Part 3 is find fg inverse and find the domain of fg inverse. Okay, let's first find fg inverse. So fg is in completed square form. You can only make x the subject when a quadratic expression is in completed square form. Okay, so y minus 1 equals 2x plus 3 squared, square root plus minus equals 2x plus 3. 3 goes to the other side, minus 3 plus minus square root y minus 1, 2 divides equals to x. So fg inverse equals minus 3. Which sign are we going to choose, plus or minus? That depends on the domain of fg. Okay. And what is going to be the domain of fg? The domain of fg will depend on the domain of g. And the domain of g is greater than 0. So the domain of fg is also greater than 0. So if x is increasing, if the domain of fg is increasing, then the range of fg inverse should also be increasing. So we're going to choose the plus sign only. Square root x minus 1 upon 2. That is g inverse of x with the plus sign only. Okay. Next part says find the domain of fg inverse. Okay. So domain of fg inverse should be equals to range of fg. And what was fg again? Fg is 2x plus 3 whole square plus 1. And we know that its domain is greater than 0, same as the domain of g. Okay. Now, if we sketch it, we should be able to tell the range of fg. So what will the sketch look like? It will have a turning point at equate 2x plus 3 to 0. So we get minus 3 upon 2, minus 1.5, comma 1. So the turning point is minus 1.5, comma 1. 1 comes from here. So somewhere over here. Okay. And its y-intercept is 10, we can see from here. So the y-intercept, it's going to be the scale of my diagram is very, very off, but you cannot do this in an exam that one in, if this distance is one, this distance has to be two. So R10 will have to go a lot higher. But since I don't have space, where I'm just using this, but don't do this in an exam. Okay. And the domain is greater than 0. So that means the graph will start from here only, where x is greater than 0. So then the range is greater than 10. So FG is greater than 10. FG uh, is greater than 10. We won't write equals to because it's x is greater than 0, not x is greater than equals to 0. So 0 is not part of the domain. So the value of y that you're getting from 0, which is 10, is not going to be part of the range. So please do not end up writing an equals to sign here. Okay, so FG is greater than 10, and that is going to be the domain of FG inverse. So this will be X is greater than 10 will be the final answer.